representing the Powertrain research, so my job is to deal with visions. Not only with visions, but also with technologies for the future. Future powertrain, that's my job I have to deal with. And this is described in this picture. Everything is covered in this one figure. So it's really complicated. Just separated into 3 sectors. If you look on the left side, the left upgoing bar, that's the primary energy. That's our roadmap, our vision. What should be our primary energy in the future? We have to have a transition from today's fossil area over new energy, primary energies like natural gas, in which form ever. And finally, we have to come to renewable base. Renewable fuels or renewable energy is the only thing which will remain if we get rid of fossil primary energy bases. The first step is fuels. Everyone is discussing about alternative fuels. But I'm not very often hear about what should be the requirement for those fuels, what is the real goal if we introduce alternative fuels. We are discussing about biofuels, but no one is discussing about the quality of biofuels. Bio is not really good or clean by itself. It's only clean and sufficient and sustainable if it's done in the right way. I personally believe that we might be able, within the next 30 years, to replace 50% of our fossil, of our current crude oil-based fuels by alternatives, and half of it might be a biofuel. So it's 25%. The other may be synthetic fuels made out of natural gas. The one is a cellulosic ethanol, because it's using straw as an input material, so it's waste material out of the food production. It's easy, it's high efficient, it has an over 90% carbon dioxide efficiency, and it's producing much more ethanol per hectare than currently out of sugar. So this is really fulfilling our sustainability criteria. And it can be blended or used as a net in our gasoline engine, so it fits somewhat in our infrastructure. There is no need for a complete new infrastructure, which although would be benefit. And the second fuel, which I really like, is a synthetic fuel out of biomass. This also fulfills our requirements. It can use roughly each cellulosic material as input. It can use wood, it can use straw, it can use hay, it can use every kind of plant material coming out of any parts or what else. I have 2 graphs here on the left side. That's a standard diesel combustion. You see 2 injections. It's pilot injection, then the main injection, followed by the starting combustion. And what you actually can see is the so-called soot lining. As we have a not homogeneous charge, so the fuel and the air is not completely homogenized, you have some portions where soot occurs in the beginning of the combustion. Then the soot later on is burned, and during this oxidation process it's sending out red light. That's a prerequisite that we have high temperatures in the areas of those soot flames, and in the same time that we have particulate emissions. Well, this is linked to NOx and particulate. If we look on the lower graphic, that's our new combustion process with this new fuel made out of biomass. It's carbon neutral, it has a CO2 efficiency of more than 90%, and as you can see here, there's absolutely no visible flame. It's a completely free pre-mixed flame and an auto-ignited flame. Hudson combustion is some 8% more efficient than today's best or most efficient diesel technology, and it has 0 NOx and 0 particulates when it can be realized like this. Though our job in the research now is to elongate this combustion to the whole area of speed and load. We are still somewhat limited, but we are already in the area we can realize 130, 140 kilometers per hour in this combustion process. And this is mostly fulfilling most of our customer demands. Though we can see there is a future of the combustion, there is a good future, and there is a clean and safe future for combustion engines.